Okay, so a bunch of absolute value equations solving for x, and we'll check for solution extraneous, those fake solutions. Uh, so let's break this one up. It's already an absolute value by itself. So x plus 9 either equals 17 or x plus 9 is the opposite of 17. And then if I subtract 9 from both sides, this will be 8. Or if I subtract 9, that'll be negative 26. And then we can check. Now, this one equals a constant at its positive, so these are going to work. Really, they get weird when they equal like x terms, or sometimes when there's weird negatives involved. So if we check, absolute value 8 plus 9, that does equal 17. That checks out. So x equals 8 works. And then if we did negative 26 plus 9, that's absolute value of negative 17, which is 17. So x equals negative 26 also works. So they're both valid answers. In part B, there's that negative 3 in front. I noticed on hand-ins and stuff like that, some people are splitting this up before getting rid of that negative 3. I wouldn't split up that absolute value into two equations until after you've dealt with that. So isolate this first. So we're going to divide both sides by negative 3. And you're going to get absolute value x plus 4 equals 7. And now the setup is a lot more like part A. So this is where we can split it into two. X plus 4 equals 7. Or the inside equals negative 7. And so then this will be x equals 3 or x equals negative 11. And then these end up both working too, because again, there's only constant. The x term's only inside the absolute value. But if we check them, then if we plug in 3 into the original, it's going to be 3 plus 4 there. So that's negative 3 times positive 7, which is negative 21, and that checks out. So x equals 3 works. If we check negative 11, then that's going to be negative 3 times negative 7 in absolute values, which is negative 3 times positive 7, which is negative 21. So x, and that works. So x equals negative 11 also works. So those are both valid. In this one, there's that 2 floating around first. So first we want to isolate the absolute value. So we're going to divide both sides by 2. So that cancels. And we're left with 4x equals 6x minus 2. And, absolute value of that. And then we can split. So over here we'll get the inside is 4x. Or the inside is negative 4x. So let me get the x's together. If I bring that 6x over, I'll get negative 2x equals negative 2. And then I'll divide both sides by negative 2, and I get 1 equals x. And then over here, if I subtract 6x, I get negative 10x over here equals negative 2. And then if I divide by 10, negative 10, I get negative 0.2. I'll do 0.2 because that's easier to see. Equals x. And then we got to check those. So if we plug them in, check. X equals 1. So if we plug in 4 times 1, that's 4. And on the other side, it's 6 times 1 minus 2 in absolute values. That's 4 equals 4. That works. So this works. And if we check negative 0.2, that's kind of weird. X equals negative 0.2. Then the left side is 4 times negative 0.2 equals... I realized I'm plugging them into this one, not the original. Although the original is really just double both sides, so it's still going to work. Sorry about that. If I wanted to be really rigorous and everything, I would have used the original instead. Okay, so we're plugging into the modified original. 6 negative 0.2 minus 2. And this side right here is negative. So a negative number can't equal, and this side on the inside is negative, but the whole number is absolute valued. So it's positive. So right here, this is false. So this is an extraneous solution and doesn't work. So you only get one answer out of this. Let's see, is there a C or a D? Yeah, there's, oh my gosh, this just keeps going. Okay, I'm going to make a separate video for those two.